In this video, I want to define the idea of orthogonal vectors. So once again, I'm going to start with two vectors u and v in Rn. We say these vectors are orthogonal if the dot product is equal to 0. So if u dot v is equal to 0, then the vectors are orthogonal. And orthogonal is kind of an extension of perpendicular. So when we're dealing with two dimensions, we have perpendicular, and in higher dimensions, orthogonal is kind of the extension of this idea of perpendicular vectors. I now want to prove the Pythagorean theorem for vectors. Two vectors u and v are orthogonal if and only if the length of u plus v squared is equal to the length of u squared plus the length of v squared. In order to prove this, I'm going to start with the left-hand side, u plus v, or the length of u plus v squared. By definition, this is u plus v dot u plus v. Using the distributive property, I can change this to u dot u plus 2u dot v plus v dot v. U dot u is by definition the length of u squared plus 2u dot v plus v dot v is the length of v squared. So in order for this to be equal to the length of u squared plus the length of v squared, we would need u dot v to be equal to 0, or orthogonal. And this goes both ways. If this is 0, then these two things are equal, and if these two things are equal, this must be 0. Another big result is the Cauchy-Schwarz Inequality, which says the absolute value of u dot v is less than or equal to the length of u times the length of v. And I won't prove this here, but it is a really important inequality when looking at the dot product in length. Another big result is the Triangle Inequality. The length of u plus v is less than or equal to the length of u plus the length of v. In order to prove this, I'm going to start with the length of u plus the length of v squared. By definition, this is u plus v dot u plus v. Using my distributive property, this is u dot u plus 2u dot v plus v dot v. This is going to be less than or equal to u dot u is by definition the length of u squared. I'm going to write this as 2 times the absolute value of u dot v. And the length of v dot v is, the length of v squared. So this inequality, if u dot v is positive, then these two things are equal. And if u dot v is negative, then by taking the absolute value, I have made it bigger. I'm then going to use my Cauchy-Schwarz inequality, which says the absolute value of u dot v is less than or equal to the length of u times the length of v. From there, I can actually factor this. So the length of u plus the length of v squared. And then taking the square root of both sides gives me my triangle inequality.